Mr. Moore's math class!
Good! Actually, guys, I don't know what time of day it is where you are right now, but what I do care about is that you are learning math from the comfort of your own house. Now today, guys, we are going to be learning all about gradients of a straight line. Now when I say the word gradient, it actually could mean a few other things. It could mean the steepness, could mean the slope, or it could also mean the rate. So what it is important that you do understand is that gradient means those three things as well. Now before we go any further, what I'm going to do is I'm going to explain some of this in a little bit more detail. So let's check it out.
This here is Jerry. You may remember him from such episodes as solving linear equations and rearranging linear equations. Say hi, Jerry. Now Jerry loves to drive, and whenever he does drive, he always drives from left to right. As Jerry moves from left to right, if he comes to a section that is going uphill, it means that he's driving along a line with a positive gradient. That is, if things are looking up, they are positive. If he is going down as he drives from left to right, it means that he is driving along a line with a negative gradient. Down means negative. A line that goes neither up nor down, that is, a flat line, has a gradient of 0. And if he drives into a brick wall, it means he's come across a line with an infinite gradient. That is, a line that goes directly up and down. Now there are three ways to find the gradient. The first one being is to use the rise and the run between 2 points. That is, the gradient is equal to rise over run, where rise is how far up or down you go between the 2 points, in this case being positive 6, and the run is how far across you have to go between the 2 points, in this case being positive 2. Using the formula now, gradient is equal to rise over run, with the rise being 6 and the run being 2, we substitute these two values in to get 6 over 2. And of course 6 divided by 2 cancels down to give us a gradient value or m value of 3. So over the next few questions, what we're going to do is we're going to have a look at how to find the gradient of a line when given different pieces of information. Now the gradient can be found using three formulas. The first formula, which you're most probably likely used to, is rise over run. So gradient is equal to rise over run. Alright, you would use this kind of example when you get given a graph that you can easily see how far it's gone up over how far it's gone across. Or if they actually tell you what the rise and the run is equal to. The next formula, which you may have seen before, is y2 minus y1 over x2 minus x1. You use this formula when you get given 2 points. And they will be given to you in x1, y1 and x2, y2. And finally, the third one, which is probably a bit new to you, is the gradient is also equal to tan theta. You use this one when you get given an angle. And the angle is always the bit that is between the right hand side of the line and the x-axis. Alright, so if you get given over here, what you need to do is find out the angle that actually is made here, the tan theta. Right, so the question up here says find the gradient of the following lines. If we have a look at this picture here, we can see that we have a y value of 14 and an x value of negative 2. Alright, what we can actually see though is this here has gone up 14 units, and this here has gone across 2 units, left to right. So you go across 2 units and up 14 units. Alright, of course the gradient's going up, therefore it's positive, so we know our answer must be positive. So always think about your answer before we go anywhere. Alright, so we need to write out gradient. So gradient is represented by the letter m. So we go m is equal to rise over run. Alright, our rise, well we know our rise goes up 14. And our run, well we're going across 2, aren't we? So that means our run is 2. The only thing that will ever be positive or negative is the rise. The run is always going to be positive. So 14 over 2 is equal to 7. Now a common mistake the number of people will make is they'll see the negative 2. Well you've got to remember that your run can only be positive. You're only going in a positive direction. It's the rise that will go up or down. So the gradient is equal to 7. What I want you to do now is pause the video and actually have a go at finding the gradient of this line using the same method that we just did. Once you're done, make sure you press play once again and have a look at my solutions. Alright, so when we actually look at this picture, what we can see is you'll see the 0, 6 and the 6, 0. That is actually Cartesian points, and it's not actually telling you the rise or the run. What it is actually telling you is at this point here, y is equal to 6, and at this point here, x is equal to 6. Alright, the x value here is 0. Well, if you think about it, along here it's going nowhere along the x-axis. It's at 0, 6, so you don't need to really worry about the 0 for this. Once again, this is telling us the x coordinate is 6, but the y coordinate is 0 because it hasn't gone up at all along here, so therefore you don't need to worry about that too much either. Alright, so let's have a look at this for a second. We know that this value here is 6. That means that from here to here we have 6 units. We also know that from the origin to here is 6 units. Alright, let's have a look at our rise. Now we start here and we know that we're actually going down rather than up, so our rise happens to be -6, which you can see here. Our run, on the other hand, well, that's always going to be positive because we're always going from left to right and we go 6 units across. So therefore -6 divided by 6 is equal to -1. Therefore my gradient is equal to -1. It's time now to have a look at the second method of how to find a gradient. And this is using the formula m is equal to y2 minus y1 over x2 minus x1. And you use this formula when you get given 2 points, as can be seen on the graph shown on the left. The first thing to do is to label the points x1, y1 and x2, y2. Substituting these values into the formula now, we put in y2 being 8, minus y1 being 2, over x2 being 2, minus x1 being 0. Remember, when substituting into a formula, always write the substituted number in brackets, as this helps you avoid making mistakes with negatives. Taking the substituted numbers out of the brackets now, you get m, or the gradient, is equal to 8 minus 2 over 2 minus 0. 8 minus 2 being 6, and 2 minus 0 being 2. And if you remember back to our previous example before, these are the same values as our rise and run. This is because to find the rise, we are essentially subtracting the height of the first coordinate being 2 from the height of the second coordinate being 8, leaving us once again with the rise of 6. And the run, of course, is the horizontal distance of the second point from the y-axis minus the horizontal distance of the first point from the y-axis. That is, in this case, 2 minus 0. So essentially this formula of m is equal to y2 minus y1 over x2 minus x1 comes from the original formula of gradient is equal to rise over run. And going back to finishing off our working out, 6 divided by 2 is 3, giving us a gradient of 3.
In this example, you're going to get given 2 points and you're going to need to use those in order to find the gradient. So let's have a go.
Alright, this type of question says find the gradient of the line passing through the points 3, -6 and -1, 8, and then b, 531 and -725. Okay, so unlike the last one where we got given a graph and we used the first method of rise over run, what we're going to now look at is the second method where we've got 2 points, because as you can see you've got 2 Cartesian points here. Now that means that we need to use this formula here, the y2 minus y1 over x2 minus x1 up here. Right, so first thing to do is write out the formula. M is equal to y2 minus y1 over x2 minus x1. Always recommend you do this because it actually helps you remember later on, so that way you don't have to keep looking through your formula sheet during tests and exams. Alright, now what we're going to do is we're going to label each point. So we're going to have x1, y1 up top and x2, y2. Because this is the first point, therefore your x and your y coordinate of the first point and your x and your y coordinate of the second point. Right, substitute these values in now. So 8 minus -6, so the 2 minuses here become a plus, so you get 8 plus 6 is equal to 14 here, and the -1 minus 3 becomes -4. Cancelling down by a common factor of 2 because 2 goes into both of these numbers, so 14 divided by 2 is 7, and -4 divided by 2 is -2, which of course gets us our final answer of -7 over 2. Make sure that we leave our answer as a fraction because it's an exact value that way. Now what I want you to do is press pause and actually have a go at part B. Okay, so once again, I've written out the formula first of all, labelled each point x1, y1 and x2, y2, substituted in the values, y2 being 25 minus y1, 31, over x2, -7 minus 5, 25 minus 31 is -6, -7 minus 5 is -12, common factor of 6 for the both of them, so 6 divided by 6 is 1, 12 divided by 6 is 2, and of course the negatives cancel out to get us positive 1/2.